First, thanks everybody for being brave enough to come to the sponsored talk. I'm going to be talking about supply chain security and secure software delivery. First, I want to talk a little bit about what supply chain security is, and I think the best way to do that is with a relatively recent example. So some of you probably remember the change files incident from back in March, was it? Yeah. So change files was a moderately popular GitHub action, and it would track files that have changed between branches. So definitely useful. And basically, an update was pushed that meant the, oh, have we gone past the page? No. That meant the action started leaking secrets to logs with a little bit of obfuscation, I think base 64 basically. And attackers could then find those secrets and exploit them. Now this affected the released version of change files. So any user that had not pinned the version to a specific older version automatically had all the GitHub secrets available to the runner exposed when it ran. And that really wasn't fun, and it affected a lot of organizations, and I guess they had a bad day while they tried to figure out the impact and rotated secrets, etc. And for a lot of people, I think that was the whole story, or the main story. But more details actually emerged over time, and it kind of got even crazier. So the first question you might kind of ask yourself is, well, how was the repository compromised? Presumably, the TG actions didn't actually mean to expose everybody's secrets. And the answer is they had a dependency on another action called ReviewDog. And ReviewDog was also compromised. In this case, the compromise came from a leaked access token. But there were some kind of slightly odd things about ReviewDog, one being that it had a very large number of contributors, and it even seemed to have some sort of automated contributor workflow where if you worked on the plugins, you could automatically get access, which seems risky, at least, although I don't think it was actually the reason for the path leaking. Anyway, the attacker got a personal access token for ReviewDog, and there was a similar attack to change files. They dumped secrets into a file and got them back later. And that's what gave them access to change files, where they kind of repeated a very similar attack. Now, I don't know how many users there are of these actions, but the main ReviewDog repo has about 8,500 stars. Change files has about 2,500. So it's probably safe to say there's hundreds, if not thousands, of affected organizations between the two attacks. And from that point of view, it kind of looks like the point was to get credentials for as many potential victims as possible, right? Because you're leaking secrets to all these hundreds of orgs, and some of them are definitely going to be slow to update and rotate and so on, and become victims. But you'd be wrong, because they're all collateral damage. There was only one target. Does anybody know what the target was? You can guess. It's kind of guessable. Any guesses? No? Okay, it wasn't government or anything. It was Coinbase. So presumably there was some crazy plan on the attacker's behalf to steal millions in cryptocurrency. It was ultimately unsuccessful, but I want you to kind of think about this from a supply chain POV. They didn't go after Coinbase head-on because they knew Coinbase's weakest link wasn't in their own security, but in security of their dependencies. They didn't even go after the change files repo directly. They went after one of their dependencies. So it was kind of sophisticated, at least insofar as it chained multiple things together, and it definitely showed some level of patience. But the thing that sort of really grinds my gears about it is he didn't care at all about all the thousands of users whose credentials got leaked. Because although the attacker might not have used them, of course the organization still had to go and update and take care of it because anybody else could access them. And anyway, I kind of hope that this one incident, which you might not have even heard of, convinces you of the importance of supply chain security. So these days, it's essential not to just look at your own infrastructure and your own code, but also the software you're using, where it comes from, how you verify its provenance, and how you keep it updated. By the way, if you want to read more about change files, go and check the Wiz blog. They have a really good sort of background in all the incidents and the review dog one. The boring slide, I'm not going to spend too long here. I do have quite an unusual surname, Mouat. So if you want to find me, you can generally, you'll find me or an Olympic curling guy who's also Scottish. But yeah, Mouat. So I'm going to move on to talk a little bit more about supply chain security, and then we'll talk about how you can prevent some of these attacks. So why are we seeing more and more supply chain attacks? And I think, and this is kind of speculation, that's a mix of opportunism and improved enterprise security. So in general, and this is definitely not a given, but in general, organizations or large enterprise organizations have reasonable security. So banks and enterprises, they're not perfect, but they do think about this stuff, and they do employ people whose full-time job it is to do security. So if you want to hack a high-value target, there's a very good chance the easiest route is to target one of their dependencies. And I guess there's also a simple numbers game. So you can compromise, a single target, or you can compromise a dependency used by tens of thousands of organizations and potentially have many more targets. There's also just a lot of places for supply chain attacks to occur. So this screenshot's from the Salsa project, and they identify where the different supply chain attacks occur. So over here in A is sort of like a malicious supplier. So if I was actually creating something that secretly stole secrets or something. So B and C is kind of where review dog and change files sit. Arguably, a better review system could have caught the malicious changes. And also, this also covers attacks like where Git can be subverted. So for example, if there's unexpected Git commits or something like that. Oh, E wasn't, yeah. So E is like the build process itself. So this is like SolarWinds, where they subverted the actual build and were able to inject malicious stuff in there. F and G, there's quite a few attacks around this level. I'll talk about some of them in other talks. And that's where the distributed binaries don't match the source code, basically. So we're not distributing what was built here. Something's gone wrong here. And yeah, I'll also talk about Chainguard libraries later on, where we try and improve that link. Consumers, H covers things like typo squatting, where you have a repository that's almost the same name as a legitimate repository, but this one's malicious. I kind of argue that's also, trying not to fall off the stage, that's also A. Consumer, that's really things more like insecure defaults. So, a lot of packages have a default username and password, and that's not a great idea. And I think the biggest problem, of course, is that every non-trivial project these days has dozens or hundreds of dependencies, and those dependencies each also have tens or hundreds of dependencies. So there's a huge scope for attackers to find a single weak point in there. Okay, so hopefully you're all sufficiently scared now. What can you actually do to prevent attacks? So I'm going to talk through a few projects, and I will mention, there's a sponsored talk, so I will mention a couple of Chainguard products at the end, but it will only be a couple of slides. So yeah, I already mentioned Salsa a second ago, but this Salsa stands for Supply Chain Levels for Software Artifacts, and it's basically an open standard. Anyone can download and use it, and it consists of 3 levels of increasing complexity for defining how secure an organization's build system is. So the first level is focused on just doing something and trying to document where things come from. Then the second is starting to add in more things like signed provenance, so you can see if something's actually changed. And you can answer a question. Say somebody says, is this your binary? You can give a definitive answer, yes or no, and you can say if it's been changed or not. And yeah, that sounds simple, but it's actually not that common to be able to answer that question. The third is starting to get pretty complex, and that's where we start looking into like proving the isolation level of build runners and so on. Yeah, and here are some of the specific criteria. So L1, choosing an appropriate build platform. So you're not doing your builds on like some developer's laptop. You're actually building in a proper secured CI/CD platform. L2, you're starting to look at isolation, and then way over in L3, you've got your improved strength of isolation and so on. Another one I want to talk about is SigStore. So a key part of provenance is signing. So cryptographic signing lets us prove someone created a given artifact. So I can say, this operating system came from Microsoft, or this container image came from Chainguard, and I can prove it. And you can also prove attestation. So you can say things like, this software was built on hardened build instance Y, for example. Now, SigStore is a signing solution, but what's really nice about it is it supports something called keyless signing. Now, it's keyless signing in the same sense that serverless is serverless. There's still keys there. It's just that you don't need to worry about keeping them secret. So previously, you would have had to create your own sort of secret pair and keep that private key secret. And frankly, it was pain, it was difficult, and I don't blame people for not doing it. But with keyless signing, we create a temporary key based on an OIDC identity. And so what you end up with is a sort of level of security that says this artifact was built by somebody who had access to this, or something that had access to this identity at this exact point in time. But yeah, amazing thing is no longer need to look after a private key. And just to show you how easy it is, I've got an example from, of course it's way down the bottom, so you're not going to be able to see it at the back. But there's a QR code as well, so you can find the link to the source code. But basically, this is a GitHub action that includes a step at the bottom to do signing. So right at the bottom, we're saying cosign, which is the SigStore CLI command, and sign --yes, and then just the name of the images. That will both sign and upload the signatures to the OCI registry. The only other thing you need is you have to make sure that this workflow has access to GitHub token. So there is a small permission change, but that's it. That's all you need to sign your images. So there's not really any excuse not to do it. Other thing I'd like to mention, this is something I worked on myself, is container hardening priorities. So this is just a bunch of criteria for assessing the security stance of container images. So there's an automated scorer. You can run it on your container images, and it'll report back on things you might want to think about improving, etc. It's split up into 4 vectors. That's them here. So there's minimalism, which is where we're thinking about how small is the image. Does it have a shell? Does it have a package manager? Then we're talking about provenance, so making sure you're only using things from trusted people, that things are signed, that versions are pinned, that you have SBOMs, etc. Fully reproducibles down the bottom, that's when you can run a build twice and get exactly the same artifact out bit for bit, which is actually turns out to be surprisingly hard, which is why it's down at this ghost chili level. Configuration metadata, that's really just setting various config and security settings that you should be doing in your container images. For example, making sure it's not running as the root user. And then we have vulnerabilities. Bruno talked about this a little bit earlier, but there are various tools like Trivy and Gripe and Sneak that you can use to scan your software, VMs, and container images, and so on, for known vulnerabilities. So these are vulnerabilities that have been posted to places like NVD, and these tools, what they do is they take inventory of all the software in your container image and cross-check it against these databases and report on what they find. And so that sounds really good, right? You're kind of thinking, well, I'll do that, and I won't let anything with a vulnerability push to production. And yeah, good luck. Because the problem is, what you're going to find is most likely the container base images or the third-party software you're using already has known CVEs, right? And then you're at this situation where you can't remediate the CVE because there's nothing to update. You're already running the latest version from the Docker Hub or whatever. And some organizations, I think some organizations, or a lot of organizations, just give up there. Some other organizations do try and investigate all the CVEs, which must be a lot of work. And there is, as you'll be unsurprised, a better solution. So this is a comparison of the Docker Hub's Python image to Chainguard's Python image. And you can see we have remediated all the CVEs. So this is a 0 CVE image at this minute. If you can't see this, but right down at the bottom, there was a day on the 10th of October. I took the screenshot this morning, by the way. There was a day on the 10th of October where there was 1 CVE. So we are actively doing things to mitigate CVEs and constantly scanning. This scan is with Gripe, so it's not something we've done ourselves. It is using third-party tooling. Also, this image is on the free tier, so you can go and try this out today. We do have, if you need like an older version of Python, or you need some other images, that may well be on a subscription basis. So Chainguard containers, we have both base images with things like Python, also Node, Java, .NET, etc., and things you place your code on top of, but also application images. So things like Redis, Nginx, Postgres, etc. And there's actually 1,700 or more images built from common open source software, so there's a very good chance you're going to find whatever you need. And there's also FIPS versions. I believe there's a talk on FedRAMP stuff from Matt Turner later, so if you're interested in that, check out the FIPS images. If you don't know what FIPS is, be very thankful. The people that know what FIPS is are now laughing. The other thing, and this is a brand new thing from Chainguard, is Chainguard libraries. I think the Python libraries just went GA. The Java ones are in beta, and I think NPM is still closed beta. But basically, we are rebuilding libraries from source. So instead of getting your libraries from NPM, Maven, or PyPy directly, you get them from Chainguard libraries. And if you use something like Nexus or Artifactory or Cloudsmith, then that should be seamless. Like your developers won't need to change anything. You'll change your settings at the registry level. You can always fall back if we don't have a given library. So what's the difference between our libraries and the ones in NPM, etc.? The big thing is we build everything from source in our hardened build factory, and we can prove that. So if the source isn't available, we're not going to build it. And that by itself cuts out a surprisingly large range of attacks. So if you think of like the recent sort of Shai-Hulud stuff, then the malicious packages were NPM published and pushed directly to NPM. So they didn't match the source in GitHub, although I know there was GitHub projects were compromised as well, but they didn't match the source code. So we would never have built that because it doesn't match. We also scan everything for malware and do CVE remediation where it makes sense. So it really is a much safer way to consume developer libraries. Okay, so I want to leave you with this quote from a ransomware hacker. He said, if all ransomware groups suddenly became cybersecurity specialists, and those who are now cybersecurity specialists began pen testing networks, the ransomware would end. And he's basically saying that the defenders can't do what the attackers can, but the attackers can do the defender's job. And I think it's spot on, and it's also pretty scary. But my small hope is that some of you, after today, will go and look at some of the tools in my talk or in the earlier talks and do some of the things there. And in that way, we kind of move the balance a tiny little bit of the way back towards the defenders. Okay, thank you very much.